Yes, so recording is in progress. You can start, please start the webinar or your presentation.
Thank you, Christian, for the introduction, and welcome everyone. Good morning, good afternoon, good evening. Looks like we have people from all over the world, which is good. I'm glad to present this topic on the Unified Architecture Framework, in particular, a new component of the UAF standard called the Enterprise Architecture Guide. So the Object Management Group develops and publishes several modeling standards, among them SysML for systems engineering, UML for software engineering, and BPMN, business process model and notation for business process engineering. And today I'm going to focus on the Unified Architecture Framework, which is for designed for modeling enterprise architectures. That includes not just system elements like hardware, software, personnel processes, but also you can model strategy, capabilities, operations, programs and projects, of course, services, resources, security, personnel, organizations, and standards. So it's a wide variety of different viewpoints of the enterprise as a whole. And the purpose of the standard is to standardize these viewpoints so you can look at other people's enterprise architecture using the same standard, and you can integrate your enterprise with their enterprise. And you can do more conventional and standardized assessment of the enterprise as a whole. So if you look at the landscape of modeling, there's always a modeling language in model-based system engineering. The premise is that you are building models not just with boxes and lines in a very informal way using PowerPoint or Visio, but you're using a more formal language such as SysML that defines your standard syntax, which is basically the grammar of the language, notation, which is the symbology, and the semantics, which is the meaning. So SysML is an example of a modeling language for system engineering. The framework here, Unified Architecture Framework, defines a number of different viewpoints. For example, operational and services and resources viewpoints. And in the case of UAF, it standardized model views, 72 of them. And for each of those model views, it provides a view specification for the tool vendors, so they have a standard way of implementing a tool plugin to create those views. UAF also has a component of the standard with a modeling language, which is essentially a modeling profile, an extension of SysML that applies SysML constructs to the 72 views defined in the UAF framework. And there's a new component, as I mentioned, the Enterprise Architecture Guide. So the UAF has been around since 2017, and there's always been a desire to have a guide, but only last year we started working on that, and it will soon be published with the next version of the framework. So the reason we have a modeling methodology is a standard way to create models of an architecture. And the reason we build models of architecture is so we can create various views to help communicate the architecture to non-modelers, such as various stakeholders like operators, users, managers, owners, and so on. And we'll usually collect these views together in some sort of architecture description. It could be a Word document, PDF, it could be a web page, it could be an HTML file. There's various ways we can put together the views to form an architecture description. And if you have subcontractors or suppliers providing components of the architecture, you can provide that architecture description to the suppliers so they can understand where their supplied components fit in the overall architecture. Also part of the modeling methodology are typically some modeling patterns, which are standard ways of building models for the organization, and some modeling templates. And sometimes the modeling templates are partially filled in with standard elements and standard constructs. So in fact, if you start building enough models, you'll start seeing that you're reusing a number of models. So you can create those models as a template that can be incorporated into your particular model set for the architecture of interest. So why do we do modeling of an architecture? Well, an architect is mainly concerned with satisfaction of concerns of the various stakeholders. Stakeholder is anybody who could be impacted by the solution that you are bringing forth, supposedly to solve some problem that some stakeholders have. And the stakeholders would have concerns about the system that you're going to engineer. And the reason we build systems is to support a number of missions that people want to use the system for. And once you start using that system to perform missions, that in turn will affect stakeholders. So it's a never-ending loop. As soon as you deploy a new system or a new version of an old system, then you're going to change the way the mission works, and you're going to affect some stakeholders in a positive way and some stakeholders in a negative way. So usually we don't have the system in front of us. Sometimes we don't have access to the system. It might be under the ocean or under the ground or up in space, or it may be too large to be putting in your lab to experiment on. So we often, even if the system is already existing that you're going to modify, we still will often characterize the fundamental properties and concepts of that system in an architecture. That architecture in turn will provide capabilities for performing the mission. So when we go characterize the architecture, we do that through architecture views, and the views will depict different aspects and properties of the architecture with respect to the concerns of stakeholders, but we'll use standardized viewpoints that correspond to those concerns. So let's say there's a safety concern, so there may be a safety viewpoint that specifies the kinds of views you would create to understand the safety characteristics of the architecture. So a unified architecture framework provides a number of standard viewpoints, as we mentioned before: the strategic, operational, services, personnel, resources, security, project, and standards. So those are the main viewpoints provided in the standard. And those viewpoints, you can think of those as corresponding to the perspectives of stakeholders that work in those areas. For example, operators work in the operational domain. Service architects, service engineers work in the service domain. People work or are part of the personnel domain. The UAF also defines a number of aspects. In the previous version of UAF, these were called model kinds, but we changed that partly because not all of these are kinds of models, and you don't necessarily have to build a model to be able to create these views from these aspects. So we organize the aspects and stakeholder viewpoints in a two-dimensional grid. So you can see the aspects going across the top. So each column represents a different kind of aspect. The motivation column in the far left, that's actually a new column in the new version 1.2 of UAF. So if you've used UAF, you may not have seen that before, but that is part of the new version. So we put requirements there. Requirements used to be a row in the bottom of the grid, but we also added strategic motivation and architecture principles in the motivation column, because that basically says why you're doing the architecture, why you're solving a particular problem. And the next three columns represent structural aspects of the architecture, and the next three, process, states, and sequences, represent the behavioral aspects. And then a number of other aspects to deal with information, parameters, constraints, and roadmap, which is basically how things evolve, change over time. And then traceability between the rows. So we put the view specifications in the grid within the intersection of a row and column. So I've highlighted one of them in the resources viewpoint row, in the processes aspect column. So we have a viewpoint, a view specification for resources processes. In other words, that's the processes, the behavioral processes performed by the resources in your architecture. So we use a 4-letter designation for these views. In this case, RS for resource and PR for process. And that makes it much easier for people to know where they are in the overall grid of the framework. So UAF itself is a 5th-generation framework. It builds upon the original framework in the U.S. Department of Defense called the C4ISR. C4 stands for Computers, Communications, Command and Control. ISR represents Intelligence, Surveillance, and Reconnaissance. Back in '96, over 25 years ago, the first framework came out, then they've revised it, and eventually they expanded it beyond C4ISR to cover more aspects of the Department of Defense. So the last version of the DODAF was 2009, and I realize not all of you work in the defense domain, which is one reason why the object management group took over, because they wanted to generalize it to all the members of the object management group. Many of we work in the commercial domain, civil domain, and public utilities, and municipalities, states, and countries. So the Unified Architecture Framework was first produced in 2017, and we've actually got a number of versions since. We're now up to version 1.2. So going back to DODAF, they had 52 views organized by those viewpoints that we saw before. Capability, data, operational project standards on the left, services and systems on the right. So now there's 72 views in the Unified Architecture Framework. So why do we have, where'd the new views come from? Well, part of the unification was expanding it beyond the U.S. Department of Defense to incorporate other frameworks, such as the Canadian framework, the NATO framework, the UK's Military Defense Framework. And we've also recently added some things from the business architecture community, from the service-oriented architecture community, and we'll continue to expand it. So you'll notice there's some empty cells in the grid, and that's because the contributing frameworks didn't have a particular view of that type. But in the future, I expect more and more of these empty cells to be populated with new views. The security views, these are the modeling concepts that relate to security. So you can model things like security enclaves, do your threat analysis, identify where your security weaknesses are and where your strong points. And then you can incorporate security controls to better address the security threats. Personnel views deal with the human resources aspects of as human components of your enterprise, and resources, including systems. So in DODAF and other frameworks, there was a systems view, but now we call that a resources view because there are more resources within an enterprise than just systems. So the Canadian framework provided the security views that got put into UAF, and the NATO framework did some work to identify some personnel views that need to be put into the UAF. It turns out the NATO framework used to have its own meta model, but in version 4 of the NATO framework, they now say you should use the UAF domain meta model to create the NATO framework views. So if you do use DODAF or any of these other frameworks, in Appendix B of the standard, there's a framework traceability report that gives you a number of mapping tables. So in this case, you can see the UAF viewpoints here on the left in this table. And then the second column is the corresponding DODAF viewpoints. And there's a separate mapping table for each of the frameworks, the Canadian framework, NATO framework, and so on. So the bottom line is you don't need to choose between those frameworks and UAF. UAF encompasses all of those frameworks. In fact, notice that there are some UAF views that have no corresponding view, such as these two at the bottom, operational traceability and parameters environment views do not have a corresponding DODAF view. So if you use UAF to build your architecture views, you will automatically be compliant with those other frameworks. So 72 views, some of you may be asking, that's way too much. I can't handle all that. Well, you don't use all of them. You use the ones that you need to express the important aspects of the architecture that you're exploring at that moment. So here's a typical selection. In my case, these are I would say the top 10 or 12 ones that I use most often. I don't do much in the services domain. I don't do much in the security domain, so you can scratch those off my list. Although in your case, you may have a lot to do with services. So you might pick some of those. And if you're worried about security, you might do some of the security views. And I don't have much to do with standards or actual resources. So four or five of the rows I don't typically do. But your situation might be different. So you can see the kind of information that are contained in these views. An operational taxonomy, for example, up here, that's going to be defining your different kinds of operational performers. Your project taxonomy shows a hierarchy of portfolios and the programs within those portfolios and the project within programs. There's a number of roadmaps, for example, capability roadmaps, system roadmaps, project timelines. So even though there's 72 views, there are just a small number of building blocks that get reused across the board when you're defining your architecture. And these come into two broad categories, behaviors and agents. Behaviors are what the enterprise is doing, and agents are the things, the entities in the enterprise that are doing the behavior. So in UAF, there's four kinds of behavior. There's capabilities at the topmost level, and that deals with high-level needs for the enterprise, and that answers the question of why does the enterprise exist. Operation activities defines what's happening in the enterprise, and sometimes we call that logical analysis or logical architecture. The functional behavior, that's more central to what system engineers do. They have what they call functional analysis. That in our case, we incorporate the functional analysis as part of the resource analysis, and that tells how you're going to solve the problem presented by the operation activities and to deliver those capabilities. And then the fourth kind of behavior is project activities. That's the who, where, and when of projects in order to produce these resource performers. So the project deliver those resource performers. Remember, one kind of resource is a system, but there's other non-system kind of resources, such as technology, software, natural resources such as air, water, and fuel. And those resource performers will implement the operational agents in your logical architecture. So each of the agents will map to the behaviors. In the case of projects, project perform activities, resource performers perform functions, operation agents perform operation activities, and enterprise phases will phase the capabilities because you don't necessarily deploy the capabilities all together at once. You typically divide that up into incremental deliveries of phases. So those functions will implement operation activities, which in turn map to the capabilities. So these are the basic building blocks within the unified architecture framework. And the bottom line is you're trying to determine what operational agents you need in your architecture that will exhibit the necessary capabilities and which resource performers will exhibit the necessary capabilities. So you can think of two kinds of capabilities, resource capabilities and operational capabilities. So the UAF specification consists of several parts. The first part is the grid with the view specifications organized by row and column. And there's the domain meta model, which is the 234 stereotypes defined within the meta model, which are extensions of SysML stereotypes and UML stereotypes. And then there's the modeling language based upon SysML. Remember, SysML is a general purpose language for system engineering, where the UAF modeling language is a specialized language for modeling an enterprise. And it's modeling the enterprise in terms of the viewpoints and aspects that show up in the grid. And if you've ever used UAF, you may remember there was a thing called the UAF profile. And we changed the name because a lot of people didn't realize the UAF profile is essentially a modeling language, but profile is a software jargon for a modeling language extension. The new component, which I'm going to focus on the rest of this hour, is the Enterprise Architecture Guide. How would you use the guide? Well, obviously, you would use it as the basis for building user models of an architecture, but you can also divide up different portions of the guide for different levels of architectures. So, for example, the Department of Defense might have an architecture at their level, and one of the services, in this case, the Air Force, might have an Air Force architecture. So there's obviously going to be some overlap between the Air Force level and the Department of Defense level. So the guide can be used to divide up the work and also identify which elements of the architecture are joint. If you're a commercial company, you may have a corporate headquarters define a business architecture for the entire organization. And there may be a business unit within the organization which has its own architecture. There may be a government agency that has an architecture for its mission, and then there may be one or more programs that have program-specific architectures. There may be also a commercial company that will flow down the architecture to its suppliers. You can also use the guide as a basis for training, so think of it like a textbook you can provide to your participants in your classes and workshops. You can also use it as the basis for creating your own organization's modeling methodology. Process guide can be instantiated in the modeling tools by the tool vendors, and we expect all the major tool vendors that provide UAF currently will also provide this Enterprise Architecture Guide as part of the plugin. So given all these views, there's a number of questions we typically get. Where do we start? Do we have to start at the top? Can we start at the bottom? Can we start on the right or the left? And which views do we need? We obviously don't want to do all the views. There's only a certain number of views that are going to be useful, and it does take a bit of effort to create these views. They don't come for free. So another question is, okay, so when I start building views, how are they related? Is there a certain sequence in which I need to build these? Because one thing precedes another in terms of some dependencies. So the guide itself is designed to answer these three questions. So to start talking about the guidance for developing an architecture according to the framework, we had to come up with a standardized workflow. And these 9 steps, steps 1 through 9, here we have step 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 steps correspond to the viewpoints within the grid. We also have step 0, which you don't have to do all the time because you may plan and prepare for architecting for the entire year. During the year, you might go to steps 1 through 9 several times. So that's why we call it step 0. And that's where you would go be tailoring this workflow and be tailoring the tools, adapting the tools to your particular situation. So the viewpoints going from top to bottom. So this does not represent a waterfall that you have to start at the top. These are more levels of abstraction. So at the top, your strategic viewpoint is the most abstract in the sense it's the furthest away from the concrete thing that you're going to build in the factory. And then the operational becoming a little more concrete, services more concrete. Eventually get down to projects that will build actual resources that exist in the real world. So everything above the actual resources is abstract in the sense that these are just definitions of the things that are in the architecture, but those definitions are used by engineers to design solutions that end up being built and put into the real world in the form of actual resources. So the workflow is following the architecting precepts that you see on the left, starting off with stakeholder concerns, drive the plan for the strategy. The strategy defines the capabilities that you're going to roll out in phases to address gaps and shortfalls. You implement the capability through operations. And all these operational concepts are implemented through services, resources, and standards and personnel. You have to deal with risk and threats to your resources and to your operations. You have to capture requirements that can flow down to the project so they can build the actual resources. So this just shows the kind of information that's produced within each of those viewpoints, and those will be captured in the architecture views defined in the framework. So the workflow is not a process, even though it looks like a process. It's really more like a work breakdown structure. It's defining all the steps involved in building all 72 views in the framework. But of course, since you're not going to use all the views, you need to tailor the workflow, and you might reuse the workflow in different steps at different levels of your architecting. For example, the enterprise itself may have an architecture, and you may only go through step 5. Whereas the various system projects might only start with step 3 or 4, because they'll use the results of step 1, 2, and 3 from the enterprise level and just add to it for the resource architectures, which represent the physical things, personnel architectures, which represent the human resources, and security architectures, which represent the resilience of your architecture to threats. The guide document has this outline. We have the obligatory front matter that OMG provides for us to put in front, such as the boilerplate, all the copyright information, and so on. So we do provide about a dozen pages for an introduction. The guide is meant for non-modelers, non-architects, non-engineers. So we try to use plain language, but you don't have to know anything about UAF to be able to read this and get an understanding of what's going on, because it's not unlikely that managers who are managing people doing modeling may not be modelers themselves. In fact, they may not even have an engineering background, especially at the enterprise level. When you do enterprise architecture, it's often system engineers that are not doing that, because then they tend to focus on the system architecture. At the enterprise level, it might be business architects or operations analysts or executive managers who have a group. Sometimes the enterprise architecture is done in the chief information office, but more and more it's the people that are doing the top level enterprise definition of the long-term strategy of the enterprise. So the introduction provides a general background of UAF and defines some of the key concepts, provide an overview of the guide. The main portion of the document is the 10 chapters dealing with the steps 0 through 9. And we have on the order of about 8 pages each. And I'll show you an example of one of the chapters. The whole thing is only about 145 pages. It's meant to be more like a reference book you put on your shelf, and you look at it now and then if you need to understand what needs to be done. It's also very handy if you're trying to figure out which views are going to make sense. So you can read what it would take to build those views and what's in those views, and see if that kind of information is what you need for your architecture. So we're going to take a look at step 3 for operational architecture. Looking at the table of contents, you can see what's in each chapter. First, we start off with the top level workflow for that particular step. Define the conceptual schema for that step. And what we mean by conceptual schema is the conceptual entities and relationships between those entities that are applicable to that particular domain. And then we go into each of the major sub-steps. In this case, there's 4 sub-steps. The first one deals with operational concepts. Second deals with the behavioral aspect, which is operational activities. And the third step deals with the structural aspects, which are the operational performers. And then it all comes together in a concept of operations in step 4. So this is what a typical page layout looks like in the document. So we start off with a short narrative giving an introduction to that major step. And then we define some of the key terms that are relevant to that step, provide that portion of the workflow with the relevant views from UAF that apply to that step. And then we Then we have, at the end, we have a summary of all the steps and the corresponding views. So underneath the entire guide is a conceptual schema, which is really the top of the pyramid. If you think of the 230 stereotypes defined by the domain meta model, this is just the 30 or so key elements that an architect or a system engineer would care about. So we use a color scheme that matches the rows in the grid. So as you can see here, the service domain elements are a salmon color. And you can see the entities named. So it has services, service architecture, service functions. They also have various kinds of rules, service contract, service policy. Each service can own a service port, which is typed by the service interface. Services can exchange operational information between them. And service exchange items will be conveyed on a service connector, which is associated with connecting different service roles. And service role is a service basically in a particular context performing a function, gives you certain service function action. And the service itself is capable of exhibiting a service kind of capability. So the relationship between the entities are the lines, and they're all labeled. So for example, a service is governed by a service contract. A service policy constrains a service. So within the operational architecture chapter, we provide this conceptual schema. You might be wondering, why are we showing more than just the operational architecture elements? So here is the operational architecture elements. There's generally operational agents, which can be an operational performer or an operational architecture. And those two kinds of operational agents are capable of performing an operation activity. And those agents can own a port typed by an interface. And the reason we put this over here is because these are the resources that can implement. So you see implement. Everything on the right can implement things on the left. So remember, the operational stuff is logical and the resources are physical. So you can see all these resource performers here can perform functions, and that function can implement an operation activity. The resource performer itself can implement an operational agent. A resource interface can implement an operational interface. So that's the general pattern, is that all the resources in your architecture can implement operational entities in your operational architecture. So we start off defining the top level workflow. As we saw before, there are 4 steps, and then there's a corresponding view in UAF correspond to that step. Notice we also have some other views outside this step that can have an influence on the views in this step. So in this case, a strategic connectivity view, which comes from step 2, can be used to inform this view. So these lines do not represent a sequence of operations. So this is not a process flow. Think of these more like influence, more like an influence diagram. So this operational taxonomy, which defines your operational performers, can influence your service taxonomy, which defines your kinds of services. So we go down one level to step 3.1. Here's the 3.1 right here. We saw above. Remember, we saw the connectivity coming in. Notice this high-level operational concept diagram can inform these 4 other views and other steps. We also show a 3rd level of the workflow. So we only go down to the 3rd level, but we go down to correspond to the individual UAF views. So step 3.12 captures the operational environment, theaters, and operating conditions, and that just it gets captured in a view called operational parameters. In this case, a special kind dealing with operational environment. So in brackets, we will indicate the corresponding DODAF view. So an OPCT, operational constraints view in UAF, correspond to the OV6A in DODAF. That makes it easier for people using DODAF and MODAF and NATO framework because they can see the designators that are relevant to what they're used to. So there is another component of the UAF standard, which is a sample problem. It defines, for all the 72 views, it defines an instance of a view for the search and rescue mission. You can see in this high-level operational concept that you have helicopters, you have rescue boats, you have a naval ship, and all these are participating in some sort of rescue at sea. In this scenario, they have a yacht that has gotten into trouble. They send a distress signal to some sort of monitor, which goes to control center, which controls the rescue assets. So this is just an example of a high-level operational concept. And DODAF, this was called an OV1. The second step, this is dealing with the operational activities. So here's the main view, operational process flows, OV5B. And here are the subordinate views. Of course, you don't have to do all these views, you just do the ones that are relevant. And you have to also decide not just which views, but what data do you need to populate those views. So in the UAF modeling language, which is another component of the spec, we define view specifications. So these are all the entities and relationships that portion of the whole meta model that apply to this particular view, in this case, the operational process view. So these are named stereotypes, which is the UML way of defining profile extensions. In this case, this is an operation activity stereotype, and it's an extension of the activity item, the activity entity in the SysML modeling language. So operational performer example, this corresponds to the SysML parameter in SysML. The operation agent corresponds to a class in UML. So it's either an extension of UML or it's an extension of SysML. An operational method is an extension of the operational. Think of these things in brackets down here as the base class. So these are extensions of those either SysML or UML base classes. So this view specification is intended for the tool vendors so they know how to build their tool plugin. But for modelers, this may be helpful to understand what are the possible kinds of things you can populate this view with, these kinds of information. Here's a sample view for an operational process. Here you can see the activity for monitoring for distress signals. The boat in distress sends a distress signal. The distress signal gets out here. Warning order gets, and the control center tells the operational assets, the rescue assets, where to navigate to the location of the victim, track where the victim is. Eventually, they find the victim, and hopefully, the end result is the victim is healthy and safe and brought back to a safe location. Step 3 is defining the operational performers in an operational taxonomy view. You can see here the 4 lower level subordinate views that correspond to information that could be used to help populate the higher level operational taxonomy view. There's a view specification for the operational taxonomy. So notice it starts off with a very basic thing at the top called a content item. And then you have different kinds of assets. In this case, resource asset or an operational asset. Resource asset could be a resource performer, which could either be a resource architecture or physical resource. And physical resource could be organizational, or it could be a resource artifact. And a special case of an artifact is software. Organizational resources could be a post, or think of that as a job position, or an organization. So you can kind of see how this all these relationships are these concepts are related to each other. Basically, start off with the most abstract thing, a concept item, and the most concrete thing on here, being a resource artifact or software, for example. Here's an example of an operational taxonomy. These are the operational performers. Here you have a command and control performer, the stress party, a searcher, and a rescuer. And we have two different kinds of rescuers and two different kinds of searchers and two different kinds of command and control. Okay, so this is the fourth step, and defining operational structure. So by convention, usually the last step has to do with analysis. In this case, you analyze the operational architecture structurally and behaviorally, and you typically will generate a concept of operations. Here's a view specification for operational structure. And we just saw that this chapter has a top-level flow dealing with these 4 steps. And we finally end up the chapter with a full listing of all the steps down to the 3rd level and the corresponding UAF views. We just saw a sample chapter for the operational architecture, step 3. One of the things you can use the enterprise architecture for is to do model-based portfolio management. So starting off with your drivers, what's driving the architecture? That's usually goals and objectives of the enterprise. It could be legislation, it could be regulations, it could be stakeholder expectations, whatever the architecture drivers are, and those change over time. So the enterprise needs to periodically adjust their architecture portfolio to respond to these new drivers. We saw the landscape of modeling, and we can see how UAF is basically a refinement of SysML, SysML being a general purpose language for system engineering. And UAF provides the enterprise modeling extensions needed in terms of standardized views, the modeling language constructs, and now the guide that helps people to understand the modeling workflow in order to build the various models and views provided by the framework. So there's other details I could provide in terms of the view specification, meta model, and the language, but I'm focusing on the guide in this particular talk. So the guide itself was designed to answer these 3 questions. So I'll stop there. We have about 15 minutes left and see what kind of question we have. I see quite a few questions.
Thanks, James, for a great presentation. Let's have a look over the questions that have been posed by the audience. We can start from the top, pick any questions you like to answer. Okay. We have 22.
Okay, so way back in slide 3, and I'll just pull that up real quick. And in some cases, I may have answered the question as I went along, because I'll just go back to the beginning. So when it was slide 3, what's the difference between a viewpoint, view specification, and a viewpoint in 4210, which is the ISO standard for architecture description. A viewpoint is it's a convention for creating the view, and the view specification is a special form of the viewpoint, particularly in a very formal language used by the tool vendors. So the viewpoint may not be as formal as the view specification. The view specification is highly technical, and that's the difference. So it does correspond to the viewpoint more or less, but there are some subtle differences which I can't go into here. Getting a copy of the UAF guide. The best way to get a copy of the UAF guide is to let me do it here. So Google OMG UAF Wiki. Okay. If you Google OMG UAF Wiki, you'll go to the wiki page. You scroll down to the bottom of that page, and where it talks about the guide, and there's a link to a PDF file. So that's the easiest way to get the guide. Okay, so there's what's the difference between a UAF and other architectures such as TOGAF. TOGAF is a framework that's mainly meant for IT architectures. So we're actually going to be working with the Open Group to kind of incorporate some of the TOGAF elements so we can better map between TOGAF and UAF. So there will always be people who use TOGAF, and sometimes they use it in conjunction with UAF. When publication of the new standard, it was just approved by the OMG board last week, so I'm expecting it just goes through some final editing. So it could be any day now. It could be next week, next month, but it won't be too long because all the approvals have been gotten. Some of the tool vendors have already incorporated. They already have a UAF plugin for version 1.2. I know I use the Cameo Enterprise Architecture tool, and they've had a technology version. It's almost like a beta copy, and once it gets formally published, they'll come back out and give you a formal version of the plugin. So UAF Grid mixes term viewpoint. So it turns out within the UAF Grid, we decided to call the rows viewpoints rather than because that better corresponds to the original frameworks. Like in DODAF, there was an operational viewpoint, and UAF there's an operational row. So we just decided to call the rows the viewpoint, although some people would say the viewpoint is actually the same thing as the view specification. So the working group for UAF, looked at the various ways we can incorporate the concept of viewpoint, and that's what we decided so far. So some people may not be happy with that because to them the viewpoint is the formal specification of the view, and it represents the things in the cells of the grid. Okay, so the question about SysML does not have semantics and syntax for model system safety concerns. That's true. There's actually a new OMG standard called RAML. It's called Risk Analysis and Assessment, and one kind of risk is a safety risk. So RAML is another OMG standard, which you will probably use in conjunction with the UAF and the version 1.3 of UAF. We plan on making better connection between the RAML language and the UAF modeling language. So we're not going to incorporate all those safety views within UAF like we did security views, because there's all kinds of different, there's not just safety, but there's also reliability. There could be secure, there could be other kinds of risk, such as cybersecurity, so on, for example. So the RAML, so expect in the future to have a RAML plugin and a UAF plugin, so you can do combined modeling and connect them together. How do you separate define from design? Not sure I understand the question. Usually, this is an architecture framework, not a design framework. So if you go into things like electrical design, mechanical design, software design, they have their own particular ways of doing things. They may or may not call it a framework. So the architecture framework is agnostic to that, and it can be used in conjunction with those design parameters used by the design engineers. So there's a comment that NATO framework cannot use the DMM because there's an implementation loop created. That gets into more detail that I can provide here, and I'm not an expert on that. So you would have to talk to the people in NATO. In fact, Jean-Luc Garnier, who works with the NATO framework, is a member of our working group, and he's helping us sort through that, and we expect to fix some of those disconnect issues in the next version of UAF. So there's a question about what's the difference between personnel and resources views. Well, think of the personnel as the human resources, and the resources views are really the non-personnel views, so such as the hardware, software, technology, and things like that. It's not a clear distinction because you can think of personnel as a subset of resources, but that's just kind of a legacy of the way we ended up. We might end up change the name of the resources viewpoint to make this more clear. But we haven't come up with a word that everybody's happy with yet. Somebody says the modeling language is confusing, not a new language. It's actually, the UAF modeling language is an extension of a later version of the Unified Profile for DODAF and MODAF, UPDM. So it turned out the first UAF profile was actually originally called UAF version 3. So it's not new in the sense that, it's new in the sense that it's model extensions, but a lot of those model extensions came from the contributing meta models from the other contributing frameworks such as DODAF, MODAF, and NATO framework. So I see, Nick, you have a lot of questions, so I think it'd be better if you and I have a conversation offline, because I don't have enough time to address all your questions, and I'm not always the expert in all these things. So we may need to have a discussion between you and some of our experts in the working group.
Let's go a little bit down to the list, and let's say start with, for example, Hillary and Thomas and Lars and yeah.
Yes. So
is there a SysML2 UAF mapping? Would be one, I guess, easy to answer question.
Yeah. So let me go down the bottom and so I'll see if I can just start from the bottom up and then see how far I can get. I got about 5 minutes left. But I think you need a minute or two to wrap it up, right?
I guess so, just less than 1 minute, but we can extend a little bit and have time until 10 minutes past 6. It's no issue for me.
Okay, so there's a question about the schemas look like OPM. Was that intentional? No. The schema notation we're using is a simplified entity relationship diagram or notation. There was no intention to be OPM-like at all. If UAF is the language, what are the corresponding tools? There are a number of tools that implement the modeling language. Rhapsody from IBM, Cameo for No Magic, now Dassault. What's the other tool? Sparks Enterprise Architecture.
Correct.
PTC tool. Well, on which SysML version is the UAF profile based? I don't know the answer to that offhand, but if you go pull up the US spec, it'll say it probably in the first paragraph. How can you get a good understanding of the UAF? Read the guide. There is no UAF for dummies yet. This guide is kind of meant for not quite dummies, but I think if you read the first 10 pages, we tried to simplify it. So I think you'll get a good understanding of UAF just by reading the introduction. Has OMG identified a list of compliant vendors? No, OMG does not certify vendors, and they do not check compliance. That you're on your own as far as checking compliance. In fact, that applies to all OMG standards. OMG will not do a certification or a compliance check. Okay, somebody says the progression of workflow forms a happy path. So in practice, all these steps are being done in parallel at the same time, even though they're numbered. They're just numbered because that's the levels of abstraction. But you can start anywhere, you can finish anywhere, and in practice, in fact, often the steps are being done by different people using their different knowledge and expertise. So the one purpose of the workflow is to help keep everybody coordinated on the team, because everybody's going to be working different portions of the architecture. There are plans to create a new version of UAF. We're actually writing the RFP right now for UAF 2.0, which will be in compliance and conformance with SysML 2.0. Is there a SysML to UAF mapping? There is in the traceability appendix. There is a mapping from the SysML basic constructs to the UAF constructs. So that should be in that appendix. It's mainly focused on enterprise architecture. Can you use it for product architecture? Of course, but you would probably not do the detailed design of the product architecture. But that you can do with SysML. In fact, not all the SysML detail constructs are in UAF. We only use the SysML constructs that we thought were relevant to modeling an enterprise. What's the semantics of operational method? I can't answer that. That's one of the it's probably best to open up the domain meta model and search for operational method, and it will give you all the semantics of that in the meta model document. Why is the operational architecture become logical, not operational? Well, the operational architecture is in the operational viewpoint, and it's not officially called logical. That's just what we informally call it, because not everybody agrees whether it's logical or not. Let me see. Some of these are just comments. Let's see if there's any other questions. I just have one more minute left. I think I answered all those questions. Do you see any that I need to
There's Jeffrey Wall. Does the use of the waterfall suggest the composition approach for arriving at requirements design? Could be interesting.
Well, as I mentioned, it's even though it looks like a waterfall, it's not. It's really layers of abstraction, levels of abstraction, and the arrows represent just getting more concrete. But you can start anywhere. You can start at the bottom and work up, middle out, top down, or do everything at the same time. So even though it looks like it's a decomposition approach, remember the workflow is meant to be used as the foundation for your methodology. Your methodology will define exactly how you will decompose and how you're going to do requirements, where you're going to do requirements, what kind of requirements, how you're going to link architecture design, and so on and so on. Every organization is different in terms of how they want to do architecture. That's why, as you can see on the screen, modeling methodology is in the middle. Everything else can be used as the foundation for building the methodology. Okay, so I'll pass it over to you to wrap things up.
Okay, thanks.